Is the air we breathe one substance? In the 18th century, Joseph Priestley and others found not just one air, but many airs or gases. Priestley produced carbon monoxide in his lab when he heated up an oxide of iron with charcoal in a gun barrel placed in a very hot furnace to see what gases were emitted. He passed the gases through a solution of lime water or calcium hydroxide to remove carbon dioxide. Priestley observed that the remaining gas burns with a blue flame. And Priestley determined the weight of the gas compared to common air. He found that carbon monoxide is almost as heavy as common air. By comparison, the gases oxygen and carbon dioxide are heavier than common air. And hydrogen is much lighter. Priestley wrote about these observations. He and others continued to investigate this gas and share credit for its discovery.
This will be a modernization of Joseph Priestley's experiments to discover carbon monoxide.
Hi, I'm Dr. Dee Castile, Associate Professor of Chemistry here at Bucknell University. In Joseph Priestley's time, they did not appreciate all the dangers of the experiments they were attempting. Priestley did not know he would generate carbon monoxide, for example. He did not know it was a poisonous gas, and he did not know he should take precautions. Today, all lab workers understand the need to work safely. For that reason, these demonstrations are being carried out in a fume hood to ensure good ventilation and to contain any spills or other mishaps. I'm wearing protection for my eyes, a lab coat, and gloves on my hands when I handle the chemicals. These are all standard measures that any chemist would take to maximize her safety in the lab. In addition, we have a typical household carbon monoxide detector to let us know if there is an unsafe buildup of carbon monoxide gas in the lab.
In a modern lab, these steps were planned in order to recreate Priestley's discovery of carbon monoxide. I prepared the sample, placed the sample in a furnace, used nitrogen gas flow to remove other gases, heated the sample to a high temperature, removed carbon dioxide, collected the gas that remained, and analyzed the gas by taking its infrared spectrum using a spectrometer. Ingredients to be used are two solids: activated charcoal, which is a form of carbon, and a special oxide of iron. The ingredients are weighed separately and then mixed together and placed in a crucible. Joseph Priestley used a charcoal-fired furnace to heat his samples. This electric furnace is a modern and much safer apparatus. The furnace is opened and the crucible with the sample is inserted. The crucible is pushed to the center of the furnace where the heat is the most stable. This plug is set to keep the sample right in the center of the furnace. The furnace is sealed and turned on. The inert gas nitrogen is fed into the furnace to purge any extra gases such as oxygen or water vapor. This blue line is the nitrogen line. Notice the pressure gauge on the nitrogen gas tank. By using this regulator, the pressure is reduced to manageable levels as it comes out of the tank. The knob on the tank is turned to start feeding nitrogen into the system. The lines to the system are opened, passing nitrogen gas through to flush away water vapor or oxygen in the system as the sample is being heated. Bubbles coming out first are from the purging gas. Later, the nitrogen gas is turned off. The sample is heated over a period of time to increasing temperatures. As the gases inside the furnace get hotter, they expand. We see bubbles of these hot gases. When the sample in the furnace gets hot enough, a gas begins to be released from a chemical reaction, and we can see a faster flow of gas bubbles than we saw with the simple expansion of hot gases. The gases given off from the sample are next passed through a scrubber to remove carbon dioxide, much as Priestley himself did. The scrubber contains aqueous sodium hydroxide, a strong base. The base reacts to capture carbon dioxide. The gas that leaves the scrubber is collected in this sample cell. The cell is transparent at each end to allow infrared waves to pass through. The cell is tilted to allow the gas to push out any air by displacement. Then stoppers are inserted in the ports of the cell. The gas sample will be analyzed by a spectrometer. The spectrometer works by passing beams of infrared radiation at different wavelengths through the sample. The rays then enter a detector, which records a spectrum of what wavelengths have been absorbed by the sample. The sample cell is inserted in the receiving chamber of the spectrometer and the cover closed. The enhanced printout of the spectrum shows the wavelengths absorbed by the gas sample. The result is this spectrum for carbon monoxide. This has been an update of Joseph Priestley's discovery of carbon monoxide, conducted in a modern and safer laboratory.
Carbon monoxide is a deadly, colorless, odorless, poisonous gas known as a silent killer because we can't see or taste it. Symptoms of carbon monoxide poisoning are similar to flu without the fever, headache, fatigue, shortness of breath, nausea, dizziness. Sources of carbon monoxide are improperly vented stoves, furnaces, and water heaters, and from automobiles, portable generators, and other engines left running in garages or in closed spaces. We are daily urged to install carbon monoxide alarms in our homes and workplaces to warn us of this deadly gas. Carbon monoxide alarms are available at hardware and home improvement stores. If the alarm signal sounds, do not try to find the source. Immediately get everyone outside to fresh air. Call 911 and let the firefighters with respirators find the reason for the alarm. Carbon monoxide has many commercial and industrial uses. With significant safety precautions, it is used in the production of detergents, liquid fuels, and other common products. And it is used to make meat appear redder on supermarket shelves. Joseph Priestley's contribution to the discovery of carbon monoxide has ongoing importance today.